A huge power outage hit Spain, Portugal, and parts of southwest France all at once, leaving millions of people without electricity. It happened on Monday morning, April 28, 2025, and caused lots of problems. Airports couldn't function, trains stopped in places like Lisbon and Madrid, and some hospitals had to cancel surgeries because they had no power. Everything just came to a stop. No one is sure yet what caused the blackout, but the company in charge of Portugal's electricity said it might have been something strange called induced atmospheric vibration. That's a rare and weird thing that can happen in the sky and might mess with power systems. It occurs when substantial changes in temperature and wind mess with giant power lines, making them wiggle and shake in strange ways. These wobbles can confuse the power system and cause big problems. So REN, the company that runs Portugal's electricity, first said that those weird wobbles might be the reason everything went dark. But later, they said that was not really what happened. According to REN, the real reason for the blackout was a huge voltage change, like a power surge, in Spain's power grid. At that moment, Portugal was using electricity from Spain. When that enormous power fluctuation hit, it triggered automatic safety systems in Portugal. Those systems shut everything down to protect power plants. Sadly, it also caused a nationwide blackout. During extreme weather in Spain, the air temperature changes fast, and that makes immense power lines stretch or shrink like rubber bands. That changes how tight they are and how they move in the wind, which can mess with both their physical balance and the electricity flowing through them, making the entire system unstable. Some experts say that if things get bad enough, this can even break power lines, cause short circuits, or even damage the towers holding up the lines. That's why safety systems are always in place. They're supposed to shut parts of the grid down automatically to stop bigger disasters. During the blackout, something like a domino effect happened. When parts of the power grid shut down, it made other parts unstable too. Some of the big electricity generators couldn't handle the chaos and had to disconnect. And when you suddenly lose those big generators, the power system can't keep up. It's something like too many people needing electricity, but not enough of it being made. It can cause even more blackouts to spread fast. Nobody knows exactly what started the blackout. Some people wondered if it might have been a cyber attack, like someone messing with the system on purpose through computers. But officials from Spain and the European Commission said that there was no proof of that. Spain's electricity company made it clear, cyber attack? Nope, that's not the problem. Still, one big reason so many places were hit is because Europe's power grids are all connected like one big web. Usually, that's a good thing, since if one country has a problem, another can help by sharing electricity. At the same time, everything has to stay super balanced. The amount of electricity being made must match how many people are using it. If even one part gets knocked out, it can mess things up for other parts nearby, especially if they were depending on it. In other words, when something big goes wrong, it can travel through that web and cause problems in lots of countries at once, just like what happened in this case. And it's not the first time this kind of thing has happened. Back in 2003, most of Italy had no power for 12 hours because of a problem with an electricity line connected to Switzerland. In 2006, overloading of lines coupled with low temperatures caused too much power to surge through Germany's grid, which ended up knocking out power in many parts of Europe. Anyway, speaking of the recent blackout, by Tuesday morning, things started getting better. Most of the lights came back on across the Iberian Peninsula. That's Portugal and Spain. All of Portugal had power again, and 99% of Spain did too. Now, the people in charge are trying to figure out exactly what went wrong and how to make sure it never happens again. So yeah, power grids are awesome when they work. When things go wrong, they can go really wrong. Now, let's travel back into the past, to the year 2012. Long time ago, huh? That's when India had one of the biggest blackouts in history. More than 600 million people lost electricity. That's like half the country or the entire population of Europe. This huge mess happened when 3 enormous power grids all broke down at once. Yep, those very grids that move electricity around. So when they fail, the lights go out everywhere. Because of this, entire cities just stopped working. Trains couldn't move, water pumps stopped, traffic lights went dark, and people were stuck all over the place. In Delhi, the capital city, the metro shut down, and passengers had to be helped off the trains. Without traffic lights, the roads turned into giant traffic jams. The blackout hit 20 of India's 28 states, including big ones like Punjab, Haryana, Uttar Pradesh, Rajasthan, and West Bengal. In West Bengal, around 200 miners got stuck underground because the elevators stopped working. Luckily, they were all rescued safely. Engineers worked all night to fix things, and by the next day, they managed to get the power back on for all 3 grids. In India, smaller power cuts happen a lot, especially in cities. That's because the country doesn't make enough electricity for everyone, and the equipment they use is pretty old. But a full grid collapse like this is rare. Before this, it happened in northern India back in 2001, so when it happened again in 2012, and across 3 grids no less, it was very important. Everything just shut down, and it showed how much the system needed fixing. But blackouts like these happened in Europe before, too. Back in 2006, something weird happened because people in Germany got cold. It was a chilly Saturday night, and families in northern Germany turned on their heaters all at once. This sudden spike in energy use put a huge load on the power grid. To make things worse, one major power cable had been turned off for a bit so a ship could pass under it. Ooh, talk about bad timing. The grid couldn't handle everything, and it started breaking down. First, Western Germany had blackouts. Then, things started going wrong in France, where even the big French power company, EDF, couldn't keep up with demand. Before long, power was going out in Paris, its suburbs, and other parts of the country. Then the trouble spread to Italy, Spain, and Belgium, and even Morocco. Millions of homes were left without power. In France alone, about 5 million people were left in the dark. Trains stopped running, and fire crews got loads of calls from people stuck in elevators. One of the people in charge said the whole thing started falling apart like a house of cards. Country after country started pulling power from France, which only made things worse. To stop a total blackout across all of Europe, they had to shut down some electricity for a short while on purpose. Over in Italy, the lights went out in both northern and southern regions. This country often imports electricity from other places, so it got hit hard. A few years earlier, in 2003, most of Italy had gone dark during another big blackout. Belgium had its own problems, while Spain saw power cuts in some of their larger cities. Even trains and high-speed rail had to stop in some places. It all started because too many people needed electricity at the same time, and the European power network couldn't keep up. Experts later said that the whole thing showed just how badly Europe needed to update and fix its old electricity systems to stop something like this. Okay, it's pop quiz time. What's the strongest river in the world? The Amazon? Pfft, rookie guess. No, really. The mightiest river isn't on land at all. It's underwater, and it's called the Antarctic Circumpolar Current, or ACC for friends. This beast flows with a force 100 times stronger than the Amazon River, and it could power over 100,000 hydroelectric plants. That's enough electricity to light up entire continents. But this underwater juggernaut doesn't just flex its muscles for fun. It's the planet's ultimate multitasker. The ACC is Earth's thermostat, carbon vacuum, climate stabilizer, and oceanic superhighway all rolled into one. But here's the not-so-fun part. Scientists have spotted a serious red flag. The ACC is slowing down. And not just by a little bit. We're talking up to 20% weaker by 2050. If this trend continues, we're looking at climate chaos that could make your worst Monday feel like a day at the spa. So, maybe time to panic a little? Well, hold on. So what is the ACC anyways? To learn more about it, we need to dive deep into the ocean, figuratively. The Antarctic Circumpolar Current is the only ocean current that flows all the way around the planet, hugging the cold continent of Antarctica like a belt of water. Unlike other currents that get tripped up by continents, the ACC has a clear racetrack, nothing but open ocean, so it flows uninterrupted through the Drake Passage between South America and Antarctica. It moves an astonishing 3.6 billion cubic feet of water per second. That's so much water we couldn't find anything to compare it to, sorry. The ACC is driven by ferocious westerly winds, moving eastward to connect the Atlantic, Pacific, and Indian Oceans into one continuous supercurrent. It also plunges into abyssal depths, connecting shallow, intermediate, and deep waters into one giant, swirling blender of oceanic energy. Now, to put it simply, it may be too late for that, but I'll try. The ACC is the glue that is keeping all of our planet together. It plays a starring role in the thermohaline circulation, or global conveyor belt, if you don't want to sound lame. This is the system that redistributes heat, carbon, and nutrients around the globe. To make it all work, the ACC pushes nutrient-rich deep water to the surface in a process called upwelling, feeding plankton, krill, whales, and eventually sushi on your plate. That means if you love seafood or care about ocean food chains at all, you should really start paying attention. Without this nutrient cycling, marine life from the bottom to the top of the food web suffers. Now, here's the cool part. While it's busy playing waiter to the sea, the ACC is also doing our laundry. Well, sort of. It absorbs massive amounts of carbon dioxide from the atmosphere and stores it in the deep ocean, locking it away for centuries. Think of it like Earth's giant carbon vault, no password required. It also helps regulate the weather. Without the ACC pushing heat around the globe, Western Europe would be 50 degrees colder. That means Paris would feel like Siberia, and Londoners would have to trade their umbrellas for snowshoes. The current helps maintain the temperature balance between the hemispheres, stabilizing wind patterns, rainfall, and ocean temperatures around the world. Even hurricane patterns could change because warm ocean surfaces are a key ingredient for cyclone formation. Mess with the currents, and you might be dialing up stronger, weirder storms. So, why is it slowing down? Well, of course, the answer is humans. You know those ice caps that are melting? Well, in Antarctica, where our friend the ACC lives, there's so much ice that if all of it melted, the Earth would rise more than 200 feet. That's taller than Cinderella's castle. What's worse, 60% of all the fresh water in the world is frozen in that ice. While that much water melting is already terrifying, it's the freshness of the water that really messes things up. You see, the ACC relies on the Southern Ocean's cold, salty water to be dense and heavy so it can sink, which helps power the current forward like a chain reaction. But when fresh water from melting glaciers pours into the ocean, it dilutes the saltiness. That makes the water less dense, so it stops sinking properly. Without that sink and flush mechanism, the ACC can't maintain its powerful flow. It's like trying to flush a toilet with no gravity. As this continues, fresh water flows north, altering the ocean's density structure and counteracting the effects of ocean warming, which normally would speed the current up. Instead, the ACC slows down. A weaker ACC means less upwelling, so fewer nutrients reach the surface. This could devastate Antarctic marine ecosystems, reducing biodiversity, collapsing fisheries, and threatening species like penguins, whales, and krill. It also opens the door in Antarctica to invasive species, like the southern bull kelp, which could throw entire food chains into chaos. Krill alone are the main food source for whales, seals, penguins, and fish. So when krill populations crash, the whole system begins to wobble like a house of cards in a hurricane. And then there's the feedback loop from hell. As the ACC weakens, more warm water can sneak southward, reaching Antarctica and melting the ice even faster. That melting will dump more fresh water into the ocean, which will weaken the current even more, which will melt more ice, and you get the idea. It's a vicious cycle. Worse still, warm waters underneath ice shelves can cause them to break apart from below, meaning the melting accelerates even when surface temperatures seem stable. Globally, the effects would ripple far and wide. Monsoons in India could become erratic, rainfall in the Amazon could drop, and agriculture from Africa to Asia could suffer. Sea levels along the east coast of North America could surge. and global weather patterns could spin into confusion. Even the Southern Ocean's ability to support commercial fisheries, like Chile's lucrative salmon industry, could decline as nutrients fail to reach the surface. And let's not forget, without a strong ACC, the ocean's ability to absorb carbon and excess heat plummets. That means that more CO2 and heat will stay in the atmosphere, making our lives even more miserable. It's like turning off Earth's air conditioner while cranking up the furnace, and burning down the pantry while you're at it. Of course, this isn't the first time things went south with the ocean currents. Before humans started heating up the planet, Earth went through a deep freeze called the Little Ice Age, and it wasn't just about colder winters. This icy chapter may have kicked off when ocean currents in the North Atlantic started acting weird. And it wasn't so long ago. This Little Ice Age had a peak in 1850, literally yesterday. Scientists believe that melting glaciers and massive exports of Arctic sea ice flooded the ocean with fresh water. That fresh water messed with the ocean's usual saltiness and density, weakening powerful systems like the AMOC, short for Atlantic Meridional Overturning Circulation. That's a mouthful. It's another crucial piece of the global conveyor belt puzzle. As these currents slowed down, less warm water reached the north, sea ice spread farther, and temperatures dropped even more. And here's the spooky part. Records from seashells near Iceland show that this shift didn't happen all at once. It came in two waves, like the planet was struggling to stay stable before tipping into a colder world. And because the AMOC is also part of the crazy life support system of planet Earth, everything is connected. Both systems are influenced by temperature, salinity, and the sinking of cold water. When the ACC slows, it can alter the balance of deep water formation and mixing, potentially weakening the AMOC too. That's a domino effect you really don't want to see. In fact, some models suggest that if both the ACC and AMOC are pushed past their tipping points, the result could be centuries of unstable climate conditions, way beyond anything modern agriculture or infrastructure is built to handle. So, next time you're sipping a cold drink or enjoying sushi, maybe raise a toast to the mighty ACC. It's doing a lot more for you than you think, and it could really use a little appreciation and less ice melting, please. So, let's consider velociraptors as pets. Yeah, walking your dino in the park, playing fetch, and we probably could have it now if it hadn't been for those pesky asteroids. To be fair, we ended up with mammals, which, let's face it, it was a pretty solid trade. But here's the big question. Why didn't reptiles make a grand comeback? Why did mammals rise instead? The answer, believe it or not, involves fungi. Yup, the same stuff that gives you athlete's foot and ruins your leftovers also wiped out dinosaurs. Welcome to the weirdest twist in extinction history. It all started with a very bad day 66 million years ago, when a 9-mile-wide asteroid crash-landed in what's now Mexico. The space rock was moving so fast that it vaporized on impact, punching out a crater 10 times its own size. Now, if you remember anything from your physics class, and no judgment if you don't, high speed means high energy. And that energy turned into a blast wave and heat so intense it could have cooked anything in the area instantly. And it didn't stop there. Tiny molten rock beads rained down globally, generating radiation equivalent to 20 million megatons. Forests caught fire, wildfires raged across continents, and the sky filled with soot and sulfuric acid. Earth turned into a planetary air fryer. Then came the blackout. With all that debris in the atmosphere, half of the sunlight couldn't reach the surface, making sea surface temperature drop by 13 degrees Fahrenheit. Within just a few weeks, the planet entered a literal impact winter. There was no sunlight for at least 2 years, and Earth experienced a 15-year-long climate collapse while the dust slowly cleared. 75% of all animal species completely disappeared. Those that survived the initial blast faced tsunamis, starvation, and the collapse of entire food chains. If you were a big animal, say over 55 pounds, your chances were basically zero. And if you were a plant, forget about it. No sunlight means no photosynthesis. And that means no plankton, no trees, no grass, and eventually no herbivores, which means no carnivores either. It was a domino effect straight into extinction. The Earth became a cold, dark graveyard. But there was one organism that looked around and said, "Yeah, this is perfect." And it was fungi. Now, fungi thrive in moist, dark, and decaying environments. You know, like a world blanketed in ash full of dead trees and rotting animals. With no sunlight and plummeting temperatures, fungi had a once-in-a-lifetime chance to take over. And they did. Fossil records show widespread fungal contamination in the period after the impact. It was a global fungal bloom, like the moldy icing on an apocalyptic cake. Now, this was great news for fungi, but terrible news for reptiles. See, fungi aren't just harmless mushrooms. Many are pathogens, and they love cold-blooded creatures. Reptiles, including some of the dinosaurs that survived, were ectothermic. This means that they relied on external heat sources to warm their bodies. In a normal situation, a nice sunny rock would do the trick. Bask in the sun, raise your internal temperature, and fight off infections. It's like an induced fever, because, unlike mammals, like me, their bodies don't do it for them. And yes, I'm a mammal too. But there was no sun, remember? And a cold reptile is a sluggish reptile. Their metabolism slows down, which might sound like a good thing, because it means they can survive on less food and oxygen. But in this new hostile world, it was a disaster. They had less energy to move, less energy to hunt, and couldn't even digest food properly. Their bodies were colder, weaker, and easier for fungi to invade. Reptile reproduction was hit hard too. Most reptiles lay eggs, which are usually buried in the soil or left in hidden nests. But with the soil now damp, cold, and riddled with fungal spores, those eggs became easy targets. Spores penetrated the thin eggshells, destroying the embryos before they could hatch. So not only were adult reptiles struggling to fight infections, but their future generations were being wiped out in the nest. This vulnerability isn't just ancient history. We still see reptiles and amphibians struggling with fungi today. There's a type of fungi, hey, you try to pronounce this, that decimated frog populations. And reptiles in colder or poorly maintained environments have to deal with fungal skin infections. Which brings us to the protagonists of the era, mammals. At the time of the impact, mammals were tiny, scrappy creatures about the size of a rat. But they had a secret weapon, actually several. First off, mammals are warm-blooded, something scientists call endothermic. They produce their own body heat, and that alone gives them a major edge, because most fungi can't tolerate temperatures above 98.6 Fahrenheit. So, while reptiles were freezing and being turned into fungal buffets, mammals were literally too hot to handle. Their warm bodies acted like natural shields against infection. And then there's reproduction. Mammals carry their young inside their bodies. This means that their developing babies were safe and warm, insulated from the hostile external environment, instead of being exposed to the unfriendly world, protected just by a fragile shell. No eggs? No problem. Their metabolism was another secret weapon. Their fast-burning energy systems let them move more, hunt more, and eat more. And because they were small, they didn't need a lot of food. And here's the cool part. Mammals probably ate fungi. Yep, the same organisms ruining the lives of reptiles. And this fungal diet might have helped them boost their immune systems, giving them an evolutionary edge. Over generations, this resistance was passed down, which explains why fungal infections mostly give us an annoying rash, but still wreaks havoc among reptiles. Of course, not all dinos were cold-blooded. In fact, some massive creatures, like the T-Rex, were warm-blooded. But, warm-blooded or not, their size worked against them. You know, giants need giant meals, and in the post-impact world, those meals didn't exist. Being warm-blooded helps, sure, but not when you're too big to feed. Small dinosaurs, however, were a different story. some survived, and we call them birds. Their small size meant they were lighter and needed less food, and their feathers helped with insulation. Being able to fly was also a flex, since they could reach food in higher places. Their beaks and guts were adapted for flexible diets, and bigger dinos were definitely picky eaters. Evolution did its thing, and the line between birds and dinos blurred forever. The same survival playbook worked for mammals. Small size? Check. Safe reproduction? Check. Versatile diets? Double check. While the rest of the world was on pause, mammals scurried through the underbrush, dodging disaster and waiting for the dust to settle. And then it did. The sun eventually came back. Plants started growing again. Life rebooted. But this time, the stage was different, with big reptiles mostly gone. No more towering predators, no more thundering herds of horned beasts. Mammals had room to stretch, and they did. They grew fast, but not too fast. Mammals never got dinosaur-sized, and that's not a coincidence. Large herbivores today, like elephants, have it easy since their food doesn't run away from them. But large predators are rare for a good reason. Hunting is hard. Your prey sees you coming, so you can't be a big, tall dummy running around. Besides, you need energy to chase, stamina to fight, and a metabolism to match. And you know how that worked out for dinos. Not to mention, mammal bones aren't built like dinosaur bones. The latter had hollow structures, even air sacs, to support their size. But if you stack too much weight on a mammal's bone, it'll snap. Nature has limits, and mammals have learned to work within them. So, when the light returned, reptiles were fewer and more fragile, clinging to the edges of ecosystems. Mammals, on the other hand, were everywhere. Before the asteroid, dinosaurs kept mammals small, and mammals, well, they didn't get much say about that. But now, with the giants gone, mammals could finally level up. And fungi? Well, they stuck around too. But mammals had already passed the ultimate test and came out on top. Thanks to their body heat, internal babies, flexible diets, and a little help from some deadly mushrooms, mammals inherited Earth. So yeah, no pet velociraptor. But maybe that's okay. You got a cat, right? Close enough. Actually, I think dogs are better. How do you feel about that? Let me know in the comments. Now imagine something so powerful that it could rip the atoms of your body apart in a fraction of a second. Ow! This something is soundlessly dashing through space, not extinct, not alive, stuck in between. If this terrifying monster were moving towards Earth, we'd be doomed. So, is it? Astronomers have found a fast and powerful space object zooming through our home Milky Way galaxy at over 110,000 miles per hour. That's faster than any rocket we've ever made. This bizarre space object got its name of a zombie star, all because it's the leftover part of a star that passed away a long time ago, but is still moving. This zombie star is a kind of an object called a magnetar, a super small, super heavy ball about the size of a city but heavier than the sun. That makes it one of the densest objects in space. Only black holes are denser. Hey, let's not forget about me, huh? Magnetars also have an incredibly strong magnetic field. The one our zombie guy has is 100 trillion times stronger than Earth's. That's so strong that if the magnetar came close to Earth, it could wipe out every credit card on the planet just from its magnetism, and we couldn't shop anymore. Plus, if a person got too close to a magnetar, like 600 miles or so, it could pull their very atoms apart, and they couldn't shop anymore. Luckily, this magnetar is very far away and not coming near us. When it was first discovered, it was about 15,000 light-years away from Earth. That's a huge distance, so you don't get to worry about your atoms being disconnected yet. Astronomers first spotted the zombie magnetar in 2008. And since only about 30 magnetars are known in our galaxy, it was a lucky and rare find. Scientists use space telescopes like Hubble and Gaia to watch it over time. That's how they discovered it was moving much faster than they thought. Now, astronomers are trying to figure out how this zombie star got such a big kick. At first, they thought that, like most magnetars, this one was born when a giant star exploded in a supernova and the leftover core became a super-dense neutron star. According to their theory, it could have happened near something called supernova remnant HB9. That would make sense since most magnetars are created this way. But when they tracked its movement, they found that the zombie star was moving too fast and going in the wrong direction to have come from HB9. They traced its path thousands of years into the past and still couldn't find any exploding star or star cluster it could have come from. This means scientists now have one more mystery on their hands. Where did this zombie star come from, and how was it made? One explanation is that it came from a white dwarf, which is the leftover core of a smaller star like our Sun after it runs out of fuel. Now normally, when white dwarfs explode, they're destroyed completely. But in rare situations, instead of blowing apart, a white dwarf might collapse into itself and turn into a neutron star. This neutron star could then become a magnetar. This unusual way of forming a magnetar also gives clues about another mystery: fast radio bursts, or FRBs. These are very quick and powerful flashes of radio energy from deep space. Some FRBs come from galaxies that are so old there shouldn't be any exploding stars left. But if magnetars can be born from collapsing white dwarfs, that might explain how those FRBs are still happening. In any case, learning how magnetars form could help us explain many strange and powerful events we see across the universe. But so far, the investigation is still on, and no answers have been found yet. Zombie stars wandering across the universe isn't the only mystery we haven't solved yet. At one point, you might come across one of them while traveling through the cosmos. It looks like nothing. At a distance of 700 million light-years away from Earth, there's a hole, a blank void that has very few galaxies. This is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there thousands of times over. It's the mysterious Bode's void in the constellation of Bodes. Yeah, makes sense. You see, galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters. But between these clusters and threads, there are huge, empty voids that hardly contain any galaxies. Such voids make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Bode's void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, I wasn't around then, all the matter in the universe was packed together quite tightly. Astronomers even thought it was something like a uniform soup. But soon, random quantum fluctuations started disturbing this matter. Some areas became denser, and their gravitational pull became stronger. They began stealing matter from less dense regions. This made such areas even denser, and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. If you visited a star cluster called Palomar 5, you'd forget all about voids and supervoids and even zombie stars. Instead, you'd need to concentrate on surviving, since the region is hiding a swarm of over 100 black holes right in the middle. And those black holes aren't just sitting there, they're at work, shaping the cluster nonstop. Palomar 5 is a group of stars located about 80,000 light-years away from us. Normally, clusters like this are dense and tightly packed, with stars all bunched up together. But Palomar 5 is different. It's spread out and has a huge tail of stars, stretching across 30,000 light-years. This beautiful tail is called a tidal stream. It's like the stars are spilling out of the cluster, creating a long river of light. Tidal streams like this are rare and hard to study. Globular clusters like this one are super old. Some are almost as old as the universe itself. But Palomar 5 also stands out because it's the only cluster we know about that still has a tidal stream attached to it, and the black holes inside the cluster might be to blame. They're pulling on the stars in the cluster, messing with their orbits, and slingshotting them right out of the cluster. Or would that be sling shooting? I don't know. Anyway, these stars are what make up the tidal stream. Over time, more and more stars get flung out. Palomar 5 has way more black holes than expected. About 20% of the cluster's mass is made up of black holes, over 100 of them, each about 20 times the mass of our Sun. Of course, Palomar 5 isn't going to last forever. In about 1 billion years, the cluster will completely fall apart. By then, all the stars will have been gone, leaving behind just the black holes. And these black holes will orbit the Milky Way, like a ghostly remnant of a cluster that used to be there. Even though this cluster is creepy enough, there's something even more eerie you can see in space: thick clouds of gas and dust called nebulae. One of the most unusual ones is probably NGC 2392, located 5,000 light-years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago and became popular because of its unusual appearance. It's basically a disk of material with a ring of comet-shaped objects. The tails of these objects stream away from the star at the center of the nebula. The bizarre orange streaks in the outer part of the cloud stretch light-years away in all directions. The middle resembles a ball of twine, but in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Wow.
On September 16th of 2023, without warning, the Earth began to hum. A low, strange vibration reverberated through the crust. This set off seismic alarms all across the globe. For 9 days straight, the planet was pulsing with this horrifying rhythm, and scientists had no idea what was going on. Meanwhile, the total disaster was happening in Greenland. It wasn't an earthquake. They knew that much. They could tell it by the rhythm. Since we all live on giant tectonic plates, they constantly move and slide on magma like icebergs on water. Sometimes, as they move, they can rub against each other or collide or break. In any case, all this causes an incredible release of energy that sends shockwaves through the ground. That's when we feel the ground literally shaking, and it's what we call an earthquake. These vibrations we feel are called seismic waves. Seismometers pick them up as pings or rumbles. In a typical earthquake, they create a bunch of different frequencies. It's a crazy chaotic mix of low and high frequencies, like smashing every piano key. What was weird about the Greenland event is that the signals weren't like that at all. It was a steady, single-frequency vibration, as if some ancient machine was stirring beneath the Earth. It's like one piano key being struck over and over, creating a doom-like, repetitive sound. Turns out, what they were hearing wasn't the noise of tectonic plates going wild. It was a phenomenon seismologists had never seen before. The days passed, and the mysterious noise just kept going. The vibrations repeated every 90 seconds, echoing around the world. The hunt for answers was growing more desperate. Seismologists had no idea what they were dealing with. They had to gather a huge international team of 68 people from 15 countries. All these scientists were gathering seismic data, satellite images, and doing some advanced math for several days, until they finally realized who the culprit was: water. It all happened in a remote, desolate region of East Greenland. This place is full of fjords, narrow inlets of the sea between high cliffs, kinda like deep water-filled valleys surrounded by towering rocky sides. In this area, surrounded by jagged peaks and icy waters, the air was still. The landscape seemingly frozen in time. Nothing here changed much for years, until one day. A colossal landslide has unfolded in the Dixon Fjord. One of those steep mountainsides towering over the fjord at almost 4,000 feet high collapsed in a massive landslide. Picture a huge chunk of this mountain crumbling and crashing down into the fjord below. This sent a deluge of rock and ice crashing into the water. The impact was just apocalyptic, 882 million cubic feet of debris. That's enough ice and rock to fill 10,000 Olympic-sized swimming pools, or 10 Great Pyramids of Giza. And all this nightmare hurled into the water with such force that it kick-started a tsunami about 360 feet high, taller than the Statue of Liberty, into the air. What's crazy is that this incredibly powerful wave was trapped in the fjord by narrow cliffs, unable to escape. It's like water sloshing in a closed bathtub. For 9 days, the mega tsunami continued to churn through it. That's why we heard this endless hum. It was a rhythmic back and forth of the water slamming against the walls. The shockwaves were rippling deep into Earth's crust, vibrations so strong that they were picked up by seismometers around the globe. This was a phenomenon so rare, so unprecedented, that it left scientists stunned. It turned out to be a perfect storm of elements. A glacier, weakened by years of warming, could no longer bear the weight of the mountain above. This collapse was inevitable, and the chaos literally shook the Earth to its core. And people often hang out in this area with cruise ships passing by. We're lucky that no lives were lost in the disaster. It was a close call though. A tourist ship stranded in the area just 2 days before narrowly escaped the tsunami's reach by pure luck. But it doesn't mean there were no losses. The waves destroyed a nearby Inuit site, which was there untouched for over 200 years. They also swept away the huts at a research station that were about 43 miles away. The vibrations traveled from Greenland to the South Pole in less than an hour. That just shows how dangerous events like this can be. And this isn't the only place where such catastrophes are happening. In the beautiful California community of Rancho Palos Verdes, the ground is shifting so quickly that it's tearing homes apart. The land there has always been kinda unstable. It has some unique geology. It's built on soft, clay-rich soil and sits on a geological fault line, which makes it prone to landslides. This means that this land is prone to slow natural shifting over many years, even when no crazy weather is happening. It's been like this for decades, but usually it's slow and pretty manageable, like about a foot a year. Imagine a tree that you played with as a kid moving 20 feet to the left as you grow up. For decades, residents adapted. They built their homes on adjustable beams. This helped the houses to move with the land. And that strategy worked well, until now. Recently, things have been getting much worse in the community. Now, the land is moving by a foot in a single week. That would be like if the same tree moved almost 960 feet since you were a child. The past 2 years have also caused some heavy rains, and the weather has been getting worse. This increased water content in the soil. The land became heavier and more prone to rapid movement. Now, this once idyllic seaside escape turned into a disaster zone. Cracks have appeared in closets, gardens, and roads, growing larger with each passing day. Streets that were once smooth are now buckled and twisted, with roads turning into a crazy theme park. Houses that once stood firm are being ripped from their foundations, some of them split in half. One of the houses had its front door 8 feet off the ground. Entire neighborhoods have been plunged into chaos. Utility companies had to switch off gas and electricity indefinitely to prevent potential disasters. The hardest hit is the coastal neighborhood of Portuguese Bend, where residents are living on the edge, literally. It always had amazing ocean views and cool sea breezes, with horses and peacocks still wandering the tree-lined streets. But now, it's like an earthquake hit. Only this time, the Earth isn't stopping. For many, this place feels like paradise, if only the land would stop shifting beneath their feet. So the locals don't give up. Some of them had to leave, but many are determined to stay and fight, despite the destruction. But they still have to pour in hundreds of thousands of dollars to save their properties. People have installed generators to keep the lights on and set up sewer systems and pumps to drain the groundwater causing the landslides. Some say that the only way for these neighborhoods to survive might be to go completely off-grid, installing power walls to store energy and stuff like that. People are trying their best to run the sewer system off generators. They hope that they could get rid of this water in the soil that's causing these hellish landslides in the first place. They're determined to fight, but they will need help and support from the government to fight this disaster. Landslides are actually more common across the US than many might think. And new maps and data show that tons of people in the country might be in danger. Scientists managed to create the first very detailed, very cool map that shows where these landslides might happen, county by county. It's based on a lot of data and the history of 1 million previous landslides. They say that nearly 40% of the United States is at risk of experiencing landslide activity, which could lead to some insane catastrophes in certain areas. Luckily, now both residents and engineers can keep this in mind. But all this shows how vulnerable we are to natural disasters, and how we should always stay alerted.
The protective shield of our planet decays and eventually fails. So do our satellites. First, communication satellites in the highest orbits go down. Next, astronauts in low Earth orbit can no longer contact their mission control center. And finally, hazardous, relentless cosmic rays start bombarding everything on Earth, causing havoc and devastation. Are these the terrifying consequences of the planet's magnetic field reversal we're going to face? Right now, as you're watching this video, Earth's north magnetic pole is extremely out of whack. It's so serious that scientists will have to update the global magnetic field model released a mere 4 years ago. Does it all mean that the magnetic pole of our planet will flip soon? Well, be patient, we'll figure it out a bit later. You see, the magnetic pole is moving quite erratically from the Canadian Arctic towards Siberia, and these movements are very unpredictable. But it's normal for the pole to be moving. There are long-term records from London and Paris that prove that the North Magnetic Pole moves randomly around the rotational North Pole over periods of several hundred years. But the most astonishing thing about its movement is that it's speeding up. Around the mid-1990s, the magnetic pole unexpectedly accelerated from a bit over 9 miles to 34 miles a year. And recently, the pole crossed the international date line, moving toward the eastern hemisphere. The European Space Agency launched extremely accurate magnetic field satellites in 2013. Thanks to them, researchers have superb data they can use not only to make magnetic field maps, but also to update them every 6 to 12 months. That's how they were able to notice that the core field was weakening too. It might be a sign that the planet's magnetic field is about to flip. To understand this process better, we need to figure out how the core field works. Let's say we've got a bar magnet that runs through the center of our planet and has a north and a south pole. This magnet is incredibly strong, representing about 75% of the intensity of our planet's magnetic field at the surface. Our bar magnet is not only moving, but is also getting weaker, by about 7% every century. Admittedly, this bar isn't the perfect representation of the core field. It's more like electric currents generating Earth's magnetic field. Still, this model makes it easier to see what's happening to our planet now. The magnetic field of our planet plays an important role in protecting us from dangerous radiation and geomagnetic activity, which is the product of the interaction between the solar wind and Earth's magnetosphere. Earth's magnetic field also moves. Scientists have been studying and tracking the movement of the magnetic poles for hundreds of years. The historical motions of these poles indicates changes in the global geometry of the magnetic field of our planet, and they may point to the beginning of the field reversal too. That's what the flip between the north and south magnetic poles is sometimes called. You see, if the north magnetic pole moves a bit, it isn't a big deal. But a complete reversal might have a serious impact on the climate of our planet, as well as modern technology. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. So those scary events from the beginning of the video aren't likely to happen to us. The magnetosphere will continue protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current is negative charges called electrons moving through the metal. The current is what generates a magnetic field. Earth has a liquid iron core. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving through the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic radiation, which otherwise would be extremely dangerous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and the magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever. But sometimes, the sun starts shedding gargantuan magnetized clouds of gas that can accelerate to incredible speeds. They're called coronal mass ejections, or CMEs. They're ejected from the sun over the course of several hours. CMEs usually look like giant twisted ropes and can occur spontaneously. Their frequency varies according to the 11-year-long solar cycle. For example, at a solar minimum, you can observe one ejection per day, and when the sun is in its most active phase, there might be 3 CMAs per day. Coronal mass ejections disrupt the calm flow of the solar wind and cause serious disturbances that can damage stuff both in space near Earth, like satellites, and on the planet's surface. If coronal mass ejections make it to Earth, their interaction with the magnetosphere generates geomagnetic storms. Those can trigger auroras, happening when a stream of energized particles hits the atmosphere and lights up. And then there are also solar flares. They develop more rapidly and with much more energy than coronal mass ejections. Solar flares often occur soon after coronal mass ejections. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. A powerful solar storm can potentially cause a devastating global blackout on Earth. If not for the Earth's magnetosphere, the effects of the sun's activity would be much more devastating. Luckily, the magnetosphere deflects most of the solar material hurtling towards our planet from our star at a speed of over 1 million miles per hour. But even so, during space weather events, there's a lot of hazardous radiation near Earth. It can potentially harm astronauts and spacecraft. Plus, space weather can damage large conducting systems, for example, pipelines and power grids, by overloading currents running inside them. Scientists regularly map and track the overall orientation and shape of our planet's magnetic field. To do it, they use local measurements of the field's orientation and magnitude. That's why they've been able to conclude that the location of the North Magnetic Pole has moved by almost 600 miles since the first measurements were taken in 1831. The magnetic field of our planet reverses on a timescale varying between 100,000 to 1 million years. One can tell how often it happens by looking at volcanic rocks at the bottom of the ocean. They capture the orientation and strength of Earth's magnetic field at the time of their creation. So, dating those rocks gives us a good picture of how our planet's magnetic field has evolved over time. From a geological point of view, field reversals happen quite fast, but they are extremely slow from a human perspective. A complete reversal normally takes a couple of thousand years, but during this time, the orientation of the magnetosphere may shift, exposing more of Earth to cosmic radiation. Such events tend to change the concentration of ozone in the atmosphere. In any case, scientists can't say for sure when the next field reversal will happen, but they keep mapping and tracking the movement of our planet's magnetic north. By the way, the Earth isn't the only planet with a magnetic field. Gas giants, like Jupiter, also have a conducting metallic hydrogen layer that generates their magnetic fields. Jupiter's internal magnetic field prevents the solar wind from interacting directly with the planet's atmosphere.
We're flying past the planets of our solar system. We pass by Mars, Jupiter, Saturn, Uranus, and Neptune. Then we move through dark space beyond the edge of our world. We've reached our destination. It's the Oort cloud. It's a hypothetical region around the solar system that holds tons of asteroids and blocks of ice. It's likely to be where the largest comet in human history was born. And now, it's heading toward the Sun. Bernard and Ellie Bernstein was discovered totally by accident during the Dark Energy Survey. Our telescopes were pointed at distant space. Their main goal was to learn more about how the universe was expanding. Astronomers also wanted to make a more detailed map of the observable universe. Scientists analyzed over 80,000 images and found a moving object. It was alarmingly close to our home planet. Its size was an impressive 62 miles. That's about the width of Lake Michigan. It was an already active comet with a long tail. Usually, comets get a tail when they come close to the Sun. The heat from the star warms the comet's surface, and light materials, like ice, begin to evaporate. This forms a cloud of steam and dust that stretches far beyond the comet. But Bernard and Ellie Bernstein is too far away from the Sun to start heating up. This means that its surface has a different composition. It might be solid carbon monoxide. This increases the luminosity of the comet. That's why it can be observed with telescopes on Earth. We can compare Bernard and Ellie Bernstein to the largest meteorite to ever fall on Earth. About 66 million years ago, our planet was hit by a meteorite about 6 miles wide. At that time, the blast wave from the collision went around Earth several times. Tsunami waves caused by the impact were taller than the largest skyscrapers, and the energy from the explosion set huge areas on fire. Almost all living creatures, including dinosaurs and ancient fish, ceased to exist. The meteorite left a crater 3 times the size of Manhattan. The place where it fell was rich in sulfur. This substance evaporated because of the abnormal heat and gathered into massive clouds. This caused acid rains that were falling on Earth for several more weeks. Our newly discovered comet is 10 times bigger. If it were flying toward Earth, you'd see it with the unaided eye long before the impact. It looked like a moving star in the night sky. A few days before the comet reached our planet, you'd see it even during the day. You'd be able to distinguish its long tail, too. When the comet entered the atmosphere, it produced a booming sound so loud you'd hear it on the other side of Earth. At this point, the comet would begin to heat up because of friction with the air. It'd start burning. Countless pieces of debris would break away from the main body of the meteorite and fall to Earth. As soon as Bernard and Ellie Bernstein touched the surface of the planet, we'd see a flash so bright it'd outshine the Sun. In a fraction of a second, a colossal amount of energy would be converted into heat. This would create the most powerful explosion in the history of our planet. It'd literally rip out chunks of ground and throw them into the air. The blast wave would incinerate everything within a few hundred miles. It continued to spread in different directions, breaking and bending trees. At one point, it reached snow-capped mountains and triggered huge avalanches that would cover many villages. The blast wave would go around the planet, shattering glass and buildings on all continents. Tsunami waves would be so high they would cover entire coastal cities. the most powerful earthquake in history would break the ground and create deep cracks. After the impact, billions of tons of dust and ash would rise into the air. A giant black cloud would completely block the sun's rays. Earth would be plunged into darkness. All the debris in the air would start melting. They'd turn into liquid lava and fall back to the surface, causing even more damage. The ash and dust in the air would cover the sun for several more months. During this time, the temperature on Earth would drop by several degrees. Even if they were hiding in deep shelters and bunkers, people, as well as all other living organisms on the planet, would be unlikely to survive this event. Fortunately, Bernardinelli Bernstein isn't going to approach Earth. Right now, the comet is about 20 astronomical units away from the Sun. That's 20 times the distance from Earth to the Sun. It means the comet will soon cross the orbit of Uranus. In 2031, it'll be 11 astronomical units away from our star. That's just outside Saturn's orbit. This is going to be the closest Bernardinelli Bernstein will approach the Sun. Then it will begin its flight back to the edge of the solar system. But the comet is bound to return again. It'll move away from the Sun and slow down until the star's gravity pulls it back. Then the comet will make another circle around our solar system, but that will take about 3 million years. Right now, we have other meteorites to worry about. For example, 3200 Phaethon. It crosses the orbits of Mars, Earth, Venus, and Mercury. Then it goes around the Sun and comes back. This cycle takes about 523 days. Then it starts over again. This meteorite is considered potentially hazardous because it crosses Earth's orbit at 7.5 Earth-Moon distances. During one of its last approaches to Earth, this 3.6-mile wide block of rock showered our planet with small meteors. Since the asteroid often passes by the Sun, its surface is most likely to look like the dry bottom of a mud swamp. It's covered in scales and cracks. As it flies past Earth, these scales break off and cause meteor showers. But the largest, potentially hazardous asteroid is the 1999 JM8. It's about the size of 77 soccer fields. It passes by Earth at 9 lunar distances. Its closest approach to our planet will happen in August 2137. If such a meteorite were to hit Earth, an entire continent could be wiped out. The rest of the world would experience massive tsunamis, but would survive the event. So naturally, scientists are thinking of ways to protect the planet from such a disaster. The first solution is a controlled Big Bang. One of the laws of physics says that if you apply some force in one direction, it'll cause a reaction in the opposite direction. So if we spot an asteroid that is about to collide with Earth, we'll need to send a rocket toward it. This way, we'll produce a controlled explosion, not inside, but right above its surface. The blast will be directed upward, and the asteroid will shift downward. Even this tiny shift would be enough to change the trajectory of the asteroid, and then it'll fly past Earth. Another way is to send a heavy object, like a spaceship, toward the space body. Every heavy object has its own gravity, so the spacecraft will have to fly close to the asteroid, which will attract the ship to its surface, but the engines of the spacecraft will resist. The ship will start pulling the asteroid in the opposite direction. This will change the trajectory of the asteroid, and our planet will remain intact. We can also ram the asteroid with the spaceship. Bam! Or we could build a space station, like the ISS. It would be equipped with a bunch of huge magnifying lenses. We would send the station closer to the Sun and start looking for potentially hazardous asteroids. Then, we'd point all the lenses so that the Sun's rays would focus on the giant rock. The heat would begin to vaporize the matter from the asteroid's surface. That's where physics would come into play again. The matter would evaporate upward, and the asteroid would move downward. We could also wrap the asteroid in a reflective film, something like foil. Usually, space bodies absorb most of the Sun's rays, but if the asteroid was covered in foil, the rays would bounce off its surface. This would create a weak pushing force. That should be enough to avoid the collision. Of course, we could attach rocket engines to the asteroid. This way, we would be able to not only change its trajectory, but also control it. But that would depend on the size of the asteroid and the number of engines. And then, we could use this massive rock to ram it into other, larger asteroids.
Whoa, something doesn't feel right. Everything seems shaky. It's definitely not an earthquake, and it's actually getting worse. The clouds seem to move quicker than usual, and the animals are going into a frenzy. The news anchor pops up on the TV in an alarmed tone and says, "Good morning. We're sorry to interrupt your program. Scientists have just discovered that the Earth's rotation has been fluctuating at an unusual rate. A group of specialists believe that the Earth is increasing its rotation with every second, and they don't know why." Even if the Earth increased its speed by 1 mile per hour, the day would only get shorter by a minute and a half or so. We wouldn't really feel it, and you could go on like nothing is happening. But as the Earth spins faster, our bodies, which are adjusted to a 24-hour timing, will have a hard time trying to cope with it. If you live by the equator, that means the rotation of the Earth is going quicker than at the North and South Pole. The area by the equator needs more time in order to complete its full rotation from the starting point. You'll experience more rain than usual. The Earth's rotation keeps the weather consistent and balanced so that nothing abnormal happens. But because the Earth is moving so fast, the weather is acting up. We'll start to see more storms and more cozy days inside, sipping on hot cocoa. Even though it seems weird, everyone can go about their day. But if the Earth picked up some speed and moved at 150 feet per second, the day would be reduced to only 22 hours. It kind of makes you feel jet-lagged 24/7. Every business works with the 24 hours a day schedule, so taking away even 2 hours can have catastrophic effects on the world economy. The whole calendar will have to change and adjust to the new timing. Clock designs will change with the new midnight, replaced with 10 o'clock. And with each week, the hours will shorten, so there will be no proper way of telling time except by sunsets and sunrises. The weather will continue to get worse and worse, feeling like the rain will never stop. The animals that rely on weather patterns won't know how to function, and mass migrations will occur from almost all species of animals. Flocks of birds will be flying everywhere and reach places they normally won't go to, affecting the whole food chain and ecology. Woods, jungles, and other places where animals roam are kept in proper balance when unaffected by humans. If it constantly rains in certain areas, then floods will force animals to move to other territories and compete with the predators in the area. If the Earth picked up speed every day, then standing on a scale in the Arctic would tell you weigh 180 pounds. But around the equator, you might weigh about 179 pounds. That's because of the extra force opposing gravity in that area. With the Earth spinning faster, all airlines around the world stop, since the radar systems have gone haywire and the weather is too dangerous to fly. Everyone has to get around by car. Satellites are positioned in such a way that it's crucial they remain where they are in order to bounce signals to us. Because of what's happening, Wi-Fi and TV signals can't go through. Communications around the world will end up short and slow. And eventually, we'll have a total communication blackout. Ships will cease to operate, and global trading will collapse, adding extra damage to the already failing world economy. Winds will get stronger and faster than usual, which means temperatures will change. Storms like hurricanes will be stronger than ever and have more energy for destruction. And still, at 100 miles per hour, the equator will now be swallowed up in the water. The Amazon basin and small islands will now completely submerge in water by around 50 feet. Most of the plant life will be in danger, especially by the equator. With woods threatened by floods, more animal environments will be in jeopardy. The trees and plants won't survive so much flooding. If the Earth rotated so fast that the hours would now be reduced to 15, then we'd probably feel like we're always on a jet plane going through turbulence. It would be impossible to sleep if the Earth kept picking up speed every second of the day. So days would be around 7 hours long as well as nights. The whole world would be flooded, except for the highest points and the tallest mountains. If that happens, humans will most likely end up there clinging to the last remaining clear patches of land. Most of the animal life will be extinct as well. And as the Earth is spinning faster and faster, the crust will lose its durability, allowing more frequent and stronger earthquakes to happen. Volcanoes will erupt all over, even if they're submerged in water. It'll go on like this for quite a while. Many major natural disasters like earthquakes, tsunamis, volcanoes, and even melting ice sheets have sped up the speed of the Earth by milliseconds. So, with the Earth's continuing speed increasing, these natural disasters will make the planet go even faster. Even if it's just for milliseconds, it's enough to have major consequences. The Earth is now spinning at 1,000 miles per hour, and as you're sitting with the rest of the survivors, you feel yourself levitating slightly. You'll see tiny pebbles and rocks floating inches from the ground. The clouds above you are passing like shooting stars. The air is thick with moisture, since water is rising to the top, forming thick clouds ready to pour. But since gravity is weaker, some of the rain is suspended in the air. Many small objects will be floating around as if you were in space. The days and nights won't be longer than a few hours. At this point, the whole world will be flooded, and the crust will be 80% gone. If it goes on any longer, there won't be any living things around, probably except for microscopic creatures that can withstand extreme and harsh conditions. The Earth would need to spin at approximately 17,600 miles per hour to cancel out the gravity for things to start floating around. At this point, all the water in the ocean will rise and look like reverse rain. The large mountain rocks will separate from the bedrock and levitate above the ground, looking like little planets in space. The Earth is now spinning 17 times faster than usual, which makes one full rotation around its axis only 84 minutes instead of 24 hours. If you manage to stay that long, then you'll literally see the days and nights go by in an instant. You'll also be floating aimlessly in the sky, bumping into rocks and other surfaces. You won't recognize anything anymore. The Earth's crust is ripping apart, exposing the magma underneath. So landing on the ground isn't an option. You'll see outer space as you go higher and higher. You won't know how fast you're going, but all you know is that you're probably the only human left in this spinning world. The Earth will eventually spin so fast that the rest of the layers will start to peel off, exposing the Earth's interior. It'll start to squeeze itself from the core until it becomes similar to a pancake. Nothing can survive at this point. So much heat will be produced from the core that the planet will heat up like a microwave. All the water will disappear, and it'll look like a red dot in the solar system. And once it starts to approach the speed of light, time will freeze. The rocks and floating elements won't move and will eventually be distorted. And with enough effort, the Earth will eventually turn into a black hole. Of course, nothing like this will ever happen. According to scientists, Earth will most likely slow down in rotation. Ever since the Moon came into the picture, the Earth has been slowing down by around 4 miles per hour every 10 million years or so. That's because of the Moon's gravitational pull on our little blue planet. It'll most likely go on that way. So hey, what's your hurry? Just recently, our Sun unleashed a supermassive solar flare. And it was the most intense one in 7 years. Solar flares are powerful explosions happening within the Sun's atmosphere, intense bursts of radiation rising from the surface of our star. How dangerous are they for us? Let's figure it out. Solar flares can indeed affect life on Earth, disrupting everything from power grids to GPS. They can have an impact on spacecraft and astronauts. They produce auroras, painting the sky with vibrant colors near our planet's poles, which is actually not a drawback but a very beautiful view. The most recent flare, part of a series of flares, was classified as an X6.3 event. This classification is based on the X-ray brightness of solar flares. There are 5 classes of solar flares, with A being the weakest and X the most powerful. Each class also has 9 subdivisions, from 1 to 9. The flare in question wasn't as monumental as the flares of September 2017. Those included an X9.3 and an X8.2. And still, it was an awe-inspiring display of energy. The flare stood out as the largest of its kind during the current solar cycle. A solar cycle is a period during which the Sun's magnetic field undergoes a complete reversal. One cycle usually lasts for about 11 years. At the moment, we're in cycle 25. It started in 2019 and is likely to last till 2030. The progression of the cycle has an impact on the star's activity levels. The Sun is quite tranquil when the activity is minimal, and at solar maximum, this activity reaches its peak. During this period, we can observe lots of solar flares and sunspots, areas where the magnetic field is around 2,500 times stronger than that on Earth and higher than anywhere else on the Sun. The particles ejected by solar flares take roughly 2 days to reach our planet. They often ignite auroras. During the most extreme solar events, these auroras can be seen not only close to the poles but also further away. Solar flares and related coronal mass ejections can pose a threat to our world that heavily depends on technology. The problem is that high-speed solar winds emanate from coronal holes. Those are openings in the Sun's magnetic field where streams of solar winds rush out of the atmosphere of our star. The plasma in these regions, with coronal holes, is cooler and denser than in other parts of the Sun's corona. Insanely fast, solar winds can worsen the situation, impacting our technology and leading to greater disruptions on Earth. You've probably seen headlines like, "Solar storms of 2025, Earth's doomsday is coming." They cause anxiety and panic. Totally unnecessary. It's true that the Sun is entering a period of increased activity, which will culminate in July 2025. But these claims about doomsdays, apocalypses, and absolute destruction are not based on scientific facts. Solar storms are just a natural phenomenon, and while they do affect our planet, experts don't expect any catastrophic events to occur even in 2025. Our power grids, communications, and GPS navigation may end up somewhat disrupted. However, the severity of the situation will depend on the direction and strength of the storm. That's what you need to know about the upcoming events. Since solar cycle 25 will most likely peak during that period, there will be more chance of observing solar flares and coronal mass ejections, CMEs. Earth might witness disruptions at different levels. Solar flares will likely interfere with radio communications and GPS navigation. And CMEs, which impact Earth's magnetic field, may trigger geomagnetic storms, potentially leading to power outages and satellite damage. We should be aware of the potential consequences of these cosmic events and take precautions like having backup power sources. But it's crucial to avoid panic. NASA and NOAA, National Oceanic and Atmospheric Administration, regularly provide updates on space weather. They actively monitor the Sun, and you can stay informed through reliable sources.
If you're a fan of Dr. Pimple Popper, you're probably freaking out right now, itching to squeeze out every little blackhead from those lip contours. But this is actually a hill formation that you can find in Garb, Sudan. Knowing that perhaps makes it all the more creepy because it looks like the crack in the middle is swallowing up everything around it. This black hole scenario brings to mind our next stop, Vostok Island. This eerie spot is a 59-acre coral atoll situated in the southwestern Pacific Ocean, about 400 miles northwest of Tahiti. If you check it out on Google Earth today, it looks like it's been totally blacked out, sparking all sorts of wild theories. People keep saying that this place is some top-secret base, or even a fictional island straight out of Lost. But what we see here is actually just a dense, dark green forest made up of Pisonia trees. Since nobody lives there and hardly anyone ever visits, the island is pretty much untouched by humans. This massive star, or mandala, is situated just outside Beatty, Nevada. It has got the internet all puzzled, with people trying to figure out if it's evidence of some kind of extraterrestrial activity. To add to the mystery, this spot is right by the Tonopah Test Range, which is also known as the famous Area 52. Despite its creepiness, it's probably just one of the thousands of crop circles that gained fame after Google Earth came along. This spiral formation right here is also located in Nevada, and it definitely looks like another chilling crop circle. But things get even stranger if you use the street view option. As you zoom in closer and closer, you'll notice that it's made up of carefully arranged rocks. This labyrinth, so to speak, is part of an open-air museum situated in the ghost town of Rhyolite. And if that's not creepy enough, take a look around and you'll see dozens of eerie men in white cloaks. Despite their lifelike appearance, these silhouettes are actually statues from an installation created by a Belgian artist in the 80s. Even stranger than stumbling upon a large circle on the ground is finding a bunch of them. Our next location in Wyoming is filled with peculiar circle structures to the point where it's hard to count them all. During the 20th century, this U.S. state shifted from a farming economy to an industrial one, dominated by the extraction of oil, gas, and coal. So, these circles are likely remnants of a tank farm. I mean, places where oil storage tanks used to be located. If you want to avoid nightmares, I highly recommend not searching for the mausoleum of Emil Becker in Poland. If you happen to find it by using the Street View mode, prepare yourself to face an abandoned place with the most terrifying sculpture there is. Oh, the creeps. Keeping on the spooky side, let's head to an isolated corner of Kazakhstan, where you can find a pentagram etched into the Earth's surface. This formation is huge, measuring roughly 1,200 feet in diameter. Before you jump to conclusions about this formation being related to some kind of underworld deity worship, it's worth noting that the pentagram actually turns out to be the outline of a park designed in the shape of a star. The star shape is marked by roadways, which are now lined with trees, making the star shape even more distinct in aerial photos. You can spot this peculiar symbol from quite a distance. At first glance, it might even resemble an otherworldly alphabet, as if a highly intelligent civilization is trying to send us an alert message. But this mystery is already solved. We are in De Hoge Veluwe, a Dutch national park located in the province of Gelderland. And these lines are actually part of the park's logo. Search for these coordinates to find what looks like a land formation straight out of an extraterrestrial landscape, or perhaps a set from Avatar. This place, located in Inner Mongolia, China, is believed to be a granite mine. But it's a bit of a mystery why it has such a striking blue tone on Google Earth. If you check it out on Microsoft Bing Maps, for example, the same location appears in a much more natural tone. In the Australian outback lies a massive geoglyph known as the Maori Man. Discovered in the late 90s, it appears to represent an indigenous Australian man hunting with a boomerang or stick. The figure stretches for more than 2 miles in length and about 1.6 miles wide. It has deep furrows carved into the ground, which adds to the complexity of its formation and origin. Despite efforts to uncover its purpose, its origin is still a mystery. This is Desert Breath, located in the Sahara. Like many things you have seen in this video, this formation also sparks speculation about it being created by extraterrestrial beings. But a quick Google search clears up that mystery. It turns out this is an art installation created by a group of 3 Greek artists back in 1997. They went all out, moving around a whopping 280,000 square feet of sand and even creating a large pool in the middle of it. Egypt still holds many mysteries, and you can explore them yourself with Google Earth. That's how some people stumbled upon this striking triangular-shaped plateau and immediately jumped to the conclusion that they discovered a hidden pyramid. However, experts quickly dashed their hopes. They believe there's no plausible explanation for a pyramid to exist in this area, located 8 miles west of the Nile Valley edge in Upper Egypt. This discovery is likely nothing more than a hill that has suffered the effects of erosion, combined with a heavy dose of wishful thinking. In some cases, nature itself is responsible for creating frightening sculptures, like the Badlands Guardian in Alberta, Canada. If you look at it from above, you'll notice not one, but two human heads emerging from the landscape. These gigantic beings were sculpted by rainwater erosion on layers of clay-rich soil. Ironically, additional human-made structures give the impression that this one is wearing wired headphones. It seems that deserts are a prime spot for discovering strange images on Google Earth. So our next stop is China. In the Gobi Desert, you'll come across zigzagging white lines that look kind of random. The first challenge for armchair experts was figuring out what these structures were made of, as it's hard to tell if they're painted on or dug into the landscape. There's still a lot of speculation about it on the internet, but the most plausible explanation is that this structure is used for calibrating satellites. This way, satellite cameras can focus on these large grids to orient themselves in space. Check out this intact plane that seems to have sunk beneath the ocean off the coast of Crooked Island, Bahamas. Some viral videos claim it's a crashed plane belonging to the infamous Pablo Escobar. The truth is that something lying on the bottom of the ocean can't be that visible, so it's more likely that it's a plane that was actually flying when Google captured these images. However, there is a strong belief that Pablo Escobar did have a plane that crashed nearby, but it was in another part of the Bahamas known as Norman's Cay. You can still spot it in shallow turquoise waters. Just search for Norman's Cay sunken plane, and there it is. If you're convinced that extraterrestrials are already among us, then go ahead and type in these coordinates on Google Earth. Explore the area using Street View, and wow, what is it? Of course, we're not talking about visitors from other planets, but this shadow of a gigantic creature still gives me the creeps. Turns out, it's just a person lugging around one of those 360-degree Street View cameras tucked away in a trekker backpack. So hey, if you take a good look around Google Earth, you might stumble upon more of these elongated necked beings walking around the globe.
Cold and seemingly infinite expanses of the Arctic. The white of the snow is blinding. In this vast and empty space, there's a dark dot. Getting closer, it turns out to be a small research station. One door and one window. An old antenna on the roof wobbles from the strong winds. You're sitting inside this hut in warm clothes, drinking hot tea. An electric generator hums under the table. It's connected to a TV and game console. You take the gamepad and select the video game you want to download. It's about 650 gigabytes. It seems in such a place it will download over several centuries. But you press the button and the game is downloaded on the console in less than a second. Welcome to the world with the fastest and most accessible internet. The internet already works at the speed of light. Phones use a specific frequency of radio waves that travel at the speed of light. You're watching this video using the internet at the speed of light. Most of the data is transmitted through a copper wire or fiber optic cable. This happens so fast that we won't notice the difference whether it's transmitted at the speed of light or not. Wi-Fi also uses radio frequencies to transmit signals between devices. The fact is that the speed of the internet is not about how fast a file travels from one device to another. It's about how much data is transmitted over a certain time. So, let's imagine that data of any size can be loaded at the speed of light. 300 gigabytes of several movies in 8K, 400 gigabytes of a video game with ultra-realistic graphics, 1 terabyte of a project for a graphics editing application, and all of this is downloaded to your device in 1/100th of a second. The internet is a connection between computers. For everything to work correctly, the computers connect to a router. This thing works as a controller. It makes sure that the message from one computer reaches the other without any confusion. When there are too many computers, you need more routers that connect to other routers. You can scale this network indefinitely. To connect millions of houses to the network, developers can use telephone cables. To make this complex system stable, it's served by internet service providers. They're companies that we pay money to access the internet. In simple terms, all information from the internet is transmitted via a cable directly to the Wi-Fi router. It uses radio waves to wirelessly transmit data to a computer or phone. Your devices are also equipped with an antenna that can catch and transmit signals via radio waves. The speed of the internet slows down when it goes through different routers, receivers, and other technical hurdles. The cable may be damaged. Providers limit the speed intentionally and increase it when you pay more money. Also, the speed of the internet is affected by the number of users connected to the same network. It's like a broad highway with a traffic jam. The more cars there are driving on it, the slower they move. Just like that, your data is loaded onto your devices. To spread the internet at the speed of light everywhere, developers need to improve cables data passes through. The number of networks and routers should be increased. The jammed highway will become even broader, and cars will be able to drive at full speed. Providers should remove all restrictions as well. Every mobile device and computer should have a high-frequency antenna that catches signals from an ultra-fast router. Several huge routers are located all over the planet. They look like enormous boxes without windows and with giant antennas on their roofs. Deep underground, thick cables providing ultra-fast data transmission are connected to these boxes. As soon as the signal from the cable enters the box, it broadcasts to space via radio waves. Thousands of satellites hover over the planet and intercept these waves to spread them throughout the world. So, anytime and anywhere, you have access to the internet that's working at the speed of light. Movies and video games are created several times faster. A lot of time is spent trying to transfer a terabyte of data with graphics from one computer to another, which is located in another country. Now, with Super Internet, developers get any amount of data in an instant. Flash drives and hard drives are no longer needed in the world. Everything is kept in cloud storage. From there, you can download any file to your computer thousands of times faster than if you downloaded it via USB. Companies that provide cloud storage services are becoming the richest in the world. You have access to the internet in the elevator and the subway, in the mines deep underground, and among the hot sands of the Sahara. The phones are released without internal memory and with an incredibly cool camera. You can record an infinite number of videos with 16K quality and not think about where to store them. You can do color correction, develop games, or edit your videos all on your phone. You don't need powerful processors for such operations. Everything works with the internet. You remotely connect to a powerful computer and work from anywhere. That's why the market for expensive computers has collapsed. Nobody wants to spend money on a cool graphics card because a new one will be released in a year. It's much easier to connect to the computer where it's already installed. Even in our time, such companies already exist in great numbers. You can play a new video game on top of settings on your old computer or phone if your internet connection is fast enough. Super Internet creates a perfect climate for the rapid development of modern technologies. Virtual reality lenses, for example. On an airplane, in a submarine, in the desert, you can watch the highest quality movies in 360 or play games with augmented reality. Special effects and graphics in such games become indistinguishable from reality. Artificial intelligence can process data from all over the world simultaneously, in seconds. Thanks to this, people make discoveries in the field of medicine and genetic engineering. Scientists are developing a machine that can upload the human mind on the internet and download it back. Each user's cloud storage accumulates so much digital garbage that people hire special companies to clean up terabytes of useless data. A huge amount of energy is consumed. It provokes an increase in the price of electricity. To save money, people build small wind farms in their backyards to generate electricity. Many people make tunnels to get to underground rivers. Using special equipment and a powerful water flow, you can create a home hydroelectric power plant. The roofs of most houses are covered with solar panels. The internet is becoming as familiar to the world as the air. There's no longer a place where you can't connect to the web. Some vloggers put a phone in a box made of refractory metals and threw it into the mouth of a raging volcano. Even then, the connection wasn't broken until the phone melted. In a few years, the data on the internet as a whole increases thousands of times. Billions of petabytes must be stored somewhere. Developers around the world build data centers to support cloud storage. They appear underwater, underground, in the mountains, and even in forests. Scientists understand there won't be enough space for such data storage in the future. In addition, all centers emit strong radiation, which is bad for humans and the Earth's atmosphere. Therefore, the world's IT companies unite to create a giant data storage server in space. They build such a station in the orbit of our planet. Developers install special equipment there to ensure the operation of cloud storage. Every year, the station grows in size. It receives energy from solar panels. After a few decades, the data center becomes a cube half the size of Earth. You can look out the window and see its outline in the blue sky, better than the moon. At night, millions of light bulbs glow on it. An enormous area on the moon is covered with solar batteries to provide the cube with additional energy. Now it looks like a disco ball. Humans colonize Mars and take the super internet there. Now you can make a high-quality video call to a friend who is on the red planet.
The Sun isn't technically the center of our solar system. It's in a space called the barycenter. It depends on which planet you're standing in. The barycenter is usually closest to the object with the greater mass. So, since we're on Earth, the true center of the solar system is the Sun, but not the center of it. With respect to Jupiter, the barycenter is actually outside the Sun's surface. Jupiter is 318 times bigger than Earth, so the balance is different. The planets don't really revolve around the Sun, but around their common center of mass. Imagine balancing a pencil on the tip of your finger. You'd have to place it right in the center so that it doesn't tip on each side. Because the pencil has its mass equally distributed, it's easy to assume that everything balances its way like that, especially in outer space. But try balancing a hammer on the tip of your toe. Chances are you'll walk out of here with a broken toe. Its true barycenter is close to the hammerhead rather than the actual center where you'd grip it. Earth and the Sun's barycenter is like that hammer. The center of mass is more or less in the center of the object. Realistically, if the Sun were to rotate around Earth, then our little blue planet would have to be just as big as the Sun, or bigger. We can't disregard the other planets in our solar system, which means they all will have to rotate around us as well. But in the ancient days, bright minds always thought everything revolved around the Earth. They called this the geocentric model, and this made sense to them because it looked like everything above us was spinning around us. The Sun and the Moon played vital roles in human history, and we didn't feel insignificant in the universe until way later on. In ancient Greece and the Middle Ages, the big brains used the geocentric model to study space. It wasn't until the 16th century that that model changed. Back in those times, they couldn't even imagine that everything revolved around the Sun, and they didn't have the knowledge to back any of this up. The Earth can't be the center of the solar system because it's not large enough for the job. For the conditions to suit the enormous size, life would have evolved differently. We'd probably be less dependent on oxygen. Some animals, like whales and dolphins, can stay for hours without taking a single breath. They can even sleep underwater. So the humans of the sun-sized Earth would have specialized lungs and wouldn't need to constantly be taking in air. It means that the plant life would be limited, with just a few shrubs here and there. There are trillions of trees around the world, but the main contributor to producing oxygen is the algae in the ocean. With such vast real estate of oceans and seas, the algae sitting on top are pumping out the air we breathe. Oxygen wouldn't be so abundant on this planet, but our breathing mechanisms might rely on carbon dioxide, another common gas found on other planets. If the planet is hot, then water will be scarce. We would only find it on certain parts of the planet, like mountaintops. The ground would be too scorched for anything to survive in properly. We can forget about seasons as well. The Sun is currently just large enough to give us what we need. But since the Earth would be so large, and the Sun would be another celestial body emanating heat, we'd always feel like we're inside a microwave. The days and nights will be different, and not much precipitation will happen. With so much heat produced in the core, earthquakes and volcanoes would likely erupt all the time. The surface would practically be a scorching plain of red magma floating around. This would be the true red planet. But if we had the same landscape like on Earth, living somewhere near the mountains could save you. The mountains would still be embedded in the core, but it would be better than staying on the ground. Some of the mountain peaks could even be 100 times taller than Mount Everest. The canyons could be so deep that the Mariana Trench would feel just like a little rupture. Animals would also behave and look different. Cold-blooded animals would have to soak up as little sun as possible so they don't burn. Animals would have to rely on migration to find water in distant lands. Birds can fly for hundreds of miles for migration season, so we'd probably see certain sleek-looking birds speeding through the air. But because gravity would be so strong on the colossal-sized Earth, the flying animals would need thinner bones and a thinner core just to take flight. The real survivors would be the microorganisms. They can live in extreme temperatures and pressures and can live without oxygen for a good while. The nights would be dark since there wouldn't be any moon to reflect the sunlight. The moon would most probably be on the opposite side of where the sun is shining, so it would forever be a floating ball in the sky. The Earth's rotational speed is the fastest at the equator, so if all the planets and the sun rotated around us, then our rotation wouldn't be so significant. New weather patterns wouldn't be good for crops. Humans would have evolved differently from what we are like now. We'd probably be shorter and stockier since gravity is so strong. And because of the soaring temperatures, we'd probably live in caves all around the world. The strongest ones would have migrated to the mountains. We'd probably have the same evolutionary path as we do now, but other physical features might be different. Our pigment would likely look different to combat the heat. The desert fox has large ears for hearing out predators and for cooling itself down in the scorching desert heat. It's possible that we would also have bigger ears than what we have now for the latter reason. We'd be a lot stronger than we are, and our bones would be thick and tough to break. Gravity is one of the key components to developing our bone density and muscle mass. This means we would unlikely need tools for hunting. This would have delayed the Bronze Age and modern civilization as we know it. With little vegetation, standing upright wouldn't be so necessary to find predators around us. We wouldn't be the fastest runners either, but we'd be strong enough to fight off a pack of strange-looking wolves. And if the Earth was supersized, then it's possible that multiple species of humans would be roaming the land in isolated areas. Some human species would grow and evolve into the intelligent thinkers of today, but some would remain the same. And some creatures from the past would still be around, unchanged. Sharks would have been around since the dinosaurs era. They wouldn't have to change their form or adapt because of their dominance. Other animals would remain the same because of their isolation. The Galapagos Island hosts some unique animals because they've been alone for so long. Without proper predators constantly lurking around them, they don't fear humans. The new mega-sized Earth would have areas as large as Asia filled with isolated animals that could remain the exact same as when they first appeared. The human species of those regions would also remain the same, since they wouldn't have moved or experimented with anything. Their diet would remain the same, and they would get used to the climate they're in. Technology would also have flourished differently in various parts of the planet. With some areas in complete isolation, they wouldn't have access to new gadgets and inventions. It would be like living on a planet with different eras in the present day. Other areas would be so advanced, they might even be flying themselves outside the planet in search of truth and answers. Our gravity is good enough for us to live properly and develop life, but if we pumped up our size to that of Jupiter, then gravity would crush us. And being the size of the Sun, Earth wouldn't even be a planet, but a brown dwarf, and would constantly be burning until it became a new sun. As of now, Earth is so small in our universe that we're practically like a grain of sand in the desert. On a cosmic level, we're an insignificant contribution to this universe.
Electronic satellites suddenly go out of control. There are voltage surges across the globe. In some places, there's a complete blackout. Scientists have little data on this incredible solar behavior, so we're still unable to accurately predict how or when exactly the next geomagnetic storm will happen. One such event took place back in July 2012, but thankfully it missed us. Not by far, though, by a mere 9 days. Just to give you a glimpse of what nearly happened, I need to explain some astronomical basics. A solar storm is a series of effects we feel here on Earth after certain events occur on the Sun. Our star is nothing more than a huge ball of molten gases that are constantly moving around, so these events happen more often than you'd think. For a solar storm to begin, our sun needs to emit bursts of energy. They're in the form of solar flares and coronal mass ejections. These two phenomena send electrical charges and waves of magnetic fields toward the Earth at an astonishing speed of about 3 million miles per hour. When these solar storms reach our planet, we can see northern lights display in locations close to the Arctic Circle. But they can also mess up satellites or other types of electronic communications. Some of these solar storms can be dangerous, and back in 2012, we came close to experiencing a very powerful one that could have had a serious outcome. The most powerful in as much as 150-plus years, based on research done by astronomers. But how did we manage to escape it? Did we have something to do with it, or was it just a pure coincidence? What we do know is that one of those coronal mass ejections did hit the Earth's orbit in late July 2012. Our planet had already left that specific location as it was on its scheduled trajectory around the Sun. So you might be asking yourself at this point, what if it didn't miss us? Turns out these intense solar storms are dangerous to all sorts of technological objects. Given we are now literally surrounded by electric objects, from our phones to our cars, try to imagine what would happen if they all stopped working all of a sudden. And here's how they work. Solar storms start with an explosion, or a solar flare. Then X-rays and UV radiation travel to our Earth at the speed of light. Some of the side effects? Well, they can include radio blackouts and GPS navigation errors. The effects can continue as minutes, or at times hours later, energetic particles reach our atmosphere. They move only a bit slower than the speed of light, but they can electrically shock the Earth's satellites and damage their components. Lastly, about a day later, clouds of magnetized plasma reach us as well. They can cause huge power blackouts, more or less paralyzing everything with an electrical plug. We might not even be able to flush our toilets, since most water supplies in cities use electric pumps these days. The effects of these geomagnetic storms would be different around the world, though. Solar storms are curious by themselves, but why do they affect some locations on Earth more than others? Based on recent research, geology has a lot to do with it. But I need to take you back a bit to paint you the bigger picture. Buckle up, because we're taking a trip in the time machine to a time when the moon didn't even exist yet. 4.6 billion years ago, our solar system looked a lot different than it does now, and that's putting it lightly. Hundreds of new planets began to form around the new sun. Planets like our own Earth, Venus, or Mars were still hurtling around the cosmos. Back in the 1970s, an astronomer named Donald R. Davis developed a theory that said the moon was born when another planet hit a newly formed Earth about 4.5 billion years ago. He also indicated that it might have been the size of Mars and later named this planet Theia. It's difficult to imagine what that impact might have looked like, even with the equipment we have these days. The astronomers suggested the giant impact hypothesis, trying to piece together this mystery. After running into our planet, the outer rocky layers of both Earth and Theia were projected into a circle of cosmic matter. Out of this debris, what we now know as the Moon was born. The Earth's core has apparently consumed Theia's iron core, that is, if it had any. Our planet also got into the position it occupies today. This way, it became more susceptible to geomagnetic storms. Back then, there was little to no information as to what might have happened to Theia, apart from giving us our only natural satellite. It took several years for a series of scientists to come up with an exciting new idea that revolutionized what we knew about our planet. What was left out of Theia is hiding under 2 continent-sized layers of rock deep within our planet. This theory is also one of the only explanations for why the moon is so dry and doesn't have much of an iron core. But Why is geology so important when it comes to geomagnetic storms? Well, that's because recent data revealed that the type of rocks below your feet can affect how well your city adapts after powerful geomagnetic storms. Some types of rock, like sedimentary rocks for example, generally have more space filled with water, which makes them electrically conductive. Other types of rocks are denser and have more resistance when it comes to electricity. Whenever such a storm happens, people living in the New England highlands may have a higher risk of experiencing major disruptions. At the same time, those in the mid-Atlantic coastal plain have less to worry about, simply due to what's hidden beneath their cities. How did we know how scary these storms are? Well, this wasn't the first time it happened. Solar storms have dazzled the astronomer community for many years now. The most iconic event of this magnitude was the Carrington Event, which happened way back in September 1859. It gave us a sneak peek of what the power of the sun is, to say the least. They named it after an English astronomer, Richard Carrington, who witnessed the solar flares himself. The power of that solar storm was something humans had never experienced before. The strong geomagnetic storm caused northern lights as far down south as the territory of Hawaii. On the morning of September 1, 1859, Richard Carrington made his way into his private observatory, located outside of London. He opened the observatory dome to have a complete view of the sky and directed his telescope to the location of the sun. He saw a bunch of huge dark spots that gleamed on the surface of our star. Shortly enough, Carrington noticed two enigmatic areas, intensely bright and full of white light bursting out from the sunspots. They disappeared 5 minutes later, but the effects carried on all across the Earth's surface. At first, later in the night, telegraph communications all around the world started to malfunction. Flashes of light started to burst from telegraph machines, disturbing the operators and even setting papers on fire. Brightly colored auroras started to appear in the nighttime skies all over the world, making confused birds chirp at night. Some people even began their daily activities, since they mistakenly thought the day had already begun. These days, our planet is laced with a mega information web, so the impact of such a solar storm would be even messier. Back in the 1800s, the telegraph system was just starting out, but this Victorian internet was an important way of sending news and private messages. Even in the United States, telegraph operators had noticed local interruptions because of thunderstorms and northern lights before. But the Carrington event and its effects were something they had never seen before. A lot of telegraph lines in North America became useless. One telegraph manager based in Pittsburgh even recalled that the currents flowing through the wires were so strong their platinum contacts were in danger of melting. Another example was that of a telegraph operator located in Washington, D.C., named Frederick W. Royce, who was hurt as his forehead touched a ground wire. Samples taken from the Earth's icy locations tell us that the Carrington effect was twice as big as any other solar storm experienced in the last 500 years. It's very difficult to imagine what the impact of a storm of that magnitude might be today. But based on a 2008 report drafted by the National Academy of Sciences, it might cost us between $1 trillion and $2 trillion in damages. There are things we can do individually to help reduce the amount of damage, though, like buying a generator or installing a backup energy supply. This can be either a solar panel or a wind turbine. More so, we can equip our houses with surge protectors that connect to our electrical panels and can save us from lightning and other power surges. The simplest solution of them all? Just unplug all the devices you're not using at any particular moment. If they aren't connected to a power source, they can't be affected by any surges.